Okay, chemical properties of alkanes and cycloalkanes. Know those terms there? This is just completing reactions. So we have combustion reactions here. I'll do this first one. I'm going to do the second one, but after I do the first one, once you get the idea, I should try to do this one as well, or before I do mine. It's when you see an alkane and oxygen, that means it's a combustion reaction. I'll probably tell you on the exam, but I don't have to. Should certainly know. And when it's a combustion reaction, the main thing that's new here that you need to put in is heat energy. You've probably seen this type of reaction in 1050 before. Pretty common. But heat energy, you have to put in there because we picture it as the pentane and oxygen come together and they just kind of fall apart into CO2. No, it burns. It burns, gives off heat and light. So it's a big, powerful reaction. We want to put that in there. Now we got to balance it. I'm not going to spend a lot of time on this because it's something you should know how to do. And of course I did that fast because I've done this before. I ran out of room earlier, but yeah, still balancing shouldn't take too long. But make sure it's balanced and make sure you have that heat energy in there. Then we have C6, so this is an alkene. But just look at the number of carbons, number of hydrogens. This is 18, so that's 9. So make sure you balance. Make sure you have CO2 and water. Make sure it's balanced. Make sure you have heat energy there, and you're all set. For this one, let me just use the back of this here first. If we have I'll do it in expanded form first. If we have an alkane plus a halogen, like chlorine, we're going to need heat and light, or heat or light. That's got to be in there, above the arrow or below the arrow. Because alkanes are very, very stable. I know they burn, but burning is a very extreme process. You can get almost everything to burn. But on its own, alkanes are pretty stable. And when you try to add chlorine or bromine or iodine or fluorine to them, they only will allow one thing to add to it. And you need heat or light to be added. You have to put energy in just to get it to happen. So it's going to extract one of the hydrogens and replace it with a chlorine. Only one. That's the big thing here. Just one. And then the hydrogen attaches to the other halogen. So we get HCl. Big thing, only one. Now you might say, well, why couldn't it attach to the second carbon? That's different. It can. Now, organic chemists could tell you the percentage of chlorines that will attach to the center versus the terminal carbon, but it doesn't matter to me. Pick any hydrogen you want in this alkane and it will count. So you can do one or the other. You don't have to put both. Just pick one hydrogen, extract it. Now I'm going to use line angle formulas, and you should get used to doing that. So for something like this, put heat or light, and you'd have this, and you put a chlorine on, and the HCl. Or, let's see, we could put the chlorine on the end, HCl, or we could put the chlorine in the center. After that, any other, we covered all the possibilities. If you put the chlorine here, it's the same as putting it here. So you say, well, which one? Whichever one you want. But Professor Champagne, which one? Put it on the end. if you need to know which one, put it on the end. That's fine. Some students, the flexibility kind of scares them, but you should get used to it when you get to the higher levels. That's what happens for a lot of problems. You get so much play, and it seems more confusing, but you really do get more independence and more flexibility. Okay, so for the bromine here, we can put one bromine, one on this end, or this carbon. If we put it here, it's the same as this one. Put it on the end, it's the same. So we could put in heat or light. Need to have that on the top. Need to have it there, because this reaction is not going to go without putting in an extra boost of energy. So it'll be this. You're going to have HBr. Only one bromine is attached. You can put it on the end, or And yeah, if you don't like that, all the different possibilities, just put it on the end. Any of them are going to be right. The only thing that's going to be wrong is if you put both bromines on at the same time. If you put both bromines on here, that means you have H2 over there. It's absolutely wrong. On my exam, I'd give you 0 points. The thing here is alkanes are very stable. Even with heat and light being used, photons being put in to try to break bonds, only one of the halogens will attach. The other one goes off with the hydrogen. Now how about this guy? Okay, I'm going to do it on another sheet of paper here. Heat or light. So this is just that problem that just ran out of room. So where does the iodine go? Well, you can put it up here, or here, or here, or here, or here. They're all the same in this case. There's no difference between these sites. If you put the iodine here, you could certainly rotate it back up. So, but only one, and you have that heat or light. And then for this guy, whoa, we got a lot of possibilities. You could put it here, which is the same as this. You can put it at this carbon, same as this. Put the carbon, put it here, or put it at this carbon, which would be the same as that. So that's up to you. And again, if you are, put it on the end. If you really don't want to mess around with it, draw the structure. And I'm going to put it about here. Got a lot of play. And again, an organic chemist would look at the structure, and they probably have a better idea of that it's more likely to form here or here, but it doesn't matter. The fluorine will attach at every site to some degree, and we're just going to go, you pick it, just make sure there's only one fluorine and it attaches the hydrogen. Or the second one attaches to the hydrogen.